In this video, I want to discuss numerical analysis of data from single subject designs. I'm distinguishing numerical analysis from statistical analysis because we're not going to look at hypothesis testing or identifying p-values. We are going to look at the numbers in the data that we get, but we're not going to be doing what I think of as a statistical analysis. The most common approach to analyzing single subject design numerically, I think, is something called the deceleration line. And what you're doing is you're identifying a line that splits the data from one phase in two. Half of the data is going to be above the line and half the data is going to be below. And then you're going to extend that line into the next phase. And if there was no difference between the two phases, you would expect that the deceleration line would also split this data in two, so that half would be above and half would be below. And if more of the data is above or more is below, that's an indication that you actually have a clinically significant difference. The way that you calculate it is you start by dividing the data within one phase. So this is all one phase here. You split the data from one phase in half, then you split it again. You find the median value in this half of the data and you plot it on this middle line. Same thing over here. And connect those two dots. That's your deceleration line. Another approach that's fairly common is something called the two standard deviation band. And what you do there is within one phase, you calculate the mean and the standard deviation of the data, and then you plot lines for two standard deviations above and below the mean, and extend those lines into the next phase. And what you're looking for is at least two consecutive data points that are outside of this band. And you can see here, all of these are consecutive data points that are outside of the band, which indicates a statistically significant or a clinically significant difference, rather.